In math, we say that two terms are like terms if they have the same variable and that variable has the same exponent. Okay, so let's look at some examples and then we'll simplify them. So if we look here at 5x plus 3x, we want to look at the variable and its exponent. So we have x, and if there's no exponent, that means the exponent's 1. Okay, we have x also to the 1. These are the same variable, same exponent. That means 5x and 3x are like terms. Okay, so yes, like terms, and if they are like terms, that means it can be simplified or they can be combined. And all we do to do that is we just look at these coefficients, 5 and 3, and in this case, because it's a plus sign, we do 5 plus 3. So 5 plus 3 is 8, and then our variable is x. Okay, next one. Let's look at the variable. Again, exponent of 1, also a y, exponent of 1. So we have two terms, and they both have y. So they are like terms. And it's just y to the 1. So now what we're going to do is look at the coefficients, and that tells us what to do with those terms. So this says 7 minus 2. Okay, so let's take off like terms. 7 minus 2 is 5, and my variable is y. All right, next one. We've got an x. This time it's squared. So let's look over here. This is also an x and squared, or to the second power. So these are also like terms, same variable and the same exponent on the variable. So we're going to look at the coefficients to tell us what to do. This one doesn't have a coefficient, and anytime there is not a coefficient, it means there's an invisible 1 there. So if it helps, go ahead and write a 1 in. Okay, and now we look at the signs here to tell us what to do. 1 plus 4, which is 5. Forgot to put my tick mark. They are like terms. Okay, and our variable and our exponent is x squared. Okay, next one. We have an x to the 1 power, but this one is a y to the 1 power. Okay, they have to be the same variable. These are not the same variable. So it doesn't matter that they both have the same exponent. They're not the same variable, so they are not like terms. That means they cannot be simplified. Okay, the next one is 8. That's just a constant. A constant means it's a number without a variable. Okay, and then we have an a cubed. So this has no variable. This has a to the 3rd power. So these are not like terms, because to be like terms, they need to be both constants or both have a cubed in them, and that's not the case. So nope, not like terms, and that means we cannot simplify it any further than what it's already stated here. Now, our expressions can get quite long and look a little bit complicated, so let's look at how we can make sense of this. We want to look for like terms, because usually we're going to be asked to simplify an expression, and that just means combine like terms. All right, and we're going to use something called the shape method. Now, once you get the hang of this, you don't need to use the shape method anymore. You could just look at it and you can combine them visually or mentally. But until we get the hang of it, we're going to do the shape method, okay? So I'm going to take my first term, which is 4x squared. So again, for like terms, I'm only focusing in on the variable and the exponent, okay? I'm going to put a box around this x to the 2 power, or squared. And now I'm going to look, are there any more x squared terms? No, constant. That's x, but it's not to the 2 power. That's just to the 1 power. X squared. Okay, great. So I'm going to put a box around this term, and I want to make sure that I put a square all the way around the sign just to the left of the number. Okay, not the sign behind it, but the sign in front of it. Okay, because this is a +2. So let's keep looking. This is an x, not to the square, so that's not a like term, and then a constant of 5. Okay, so let's go to the next term. We have an 8. I'm going to underline my constants. This is an x, so that's not a constant. This one's an x, not a constant. Again, that's for the 1st power. And then I have 5. That is a constant. So I'm going to underline, including the sign. So include my +8 and my +5. All right, next one. We're going to go to 3x. So my term here is x, and it's x to the 1st power. So I'm going to circle this for 1, including my plus sign. And I'm going to look for other x terms, x to the 1 power. Okay, so I have x to the 1 power. Great, I'm going to circle that, including the sign. Okay, remember that the coefficients do not have to be the same. It does not matter. This is a 3 and this is a 1, right? If there's no coefficient there, it does not mean 0. It means 1. Okay, so we have 1x to the 1 and we have 3x to the 1. So x to the 1 is the only thing that matters. So let's go ahead and combine or simplify this term. Let's start with our x squared. We have 4x squared plus 2x squared. So let's look at these coefficients. 4 plus 2 is 6. So I have 6x squared. The next thing I'm going to look at is my constant 8 here, 8, and I have a plus 5. 8 plus 5 is 13. Now, I see sometimes that students will write this, but there needs to be an operation there. This is all addition and subtraction. We're not multiplying these terms, we're adding and subtracting them. So 8 plus 5 is a positive 13, so we're going to write a plus 13 there. The next one is x, my x terms that are circled. So 3 minus 1 is 2. Still a positive 2 though, right? So plus 2, and my variable is x. So this is my term, or my expression simplified. Okay, let's pick up the pace a little bit here. We're going to do x squared. We're going to box it. Let's look for another x squared. X to the 1, x squared. Remembering to include our sign. No more x squareds. Let's look at our constant. Do we have any constant? Yes, a minus 10. We're going to underline that. And then we're going to circle any x terms. There's no more x terms. Okay, so what can be simplified? Well, x squared and x squared. 7 minus 5 is 2x squared. And then these ones don't have anything to combine, and that is totally fine. Okay, so we're going to write plus 3x. Oops, I should use my other pen. And my minus 10. Okay, so that is okay that these are not simplifying any further. We just copy them down here at the bottom. All right, let's go down to our next one. Let's take the first term here. This one's a 20d. I'm going to box the d's. Any more d's? No, d squared. That's not the same, and that's just a constant. Okay, now we've got a, so I'm going to circle my a's, including that minus. Oh, another a term. Let's go ahead and circle this, including that plus sign. All right, now we've got a d squared term. Okay, what am I going to do with this? Well, I could do like a, I don't know, a triangle around this guy. It's kind of a wonky looking triangle. Looks more like a trapezoid. Okay, and I don't have any more d squared terms. And then I have a constant. So I'm going to go ahead and underline this constant. Okay, is there anything here that we can combine? That 20d has nothing to combine with. So we're just going to copy it down. Oopsie, 20d. Okay, then I have two a's. So minus 5 and plus 8. When I have this, I could actually put them in any order. So it's the same thing as 8 minus 5. Which is 3a, and then I have a 3d squared, and then a plus 1. Okay, so that's our expression simplified. I hope that helps.